Hello and welcome back to the beach. Today what we're looking at is the high-low cost estimation method. And what the high-low cost estimation method allows me to do is try to identify an analysis of the behavior of costs and levels of production. It begins with an assumption that there is a relationship between these two different things, and the relationship will be based on a mixture of fixed costs and variable costs. So the fixed cost element is where this blue line goes through my y-axis. The y-axis is the one labeled with a dollar sign. And also the levels of quantity of production, which is my x-axis labeled with a Q for quantity. So total cost is a fixed cost element and a variable cost element together. And what happens is, if we make the assumption that there is some sort of relationship, which is a reasonable assumption, we can now start thinking about looking at actual results in the past and see if we think it looks like there should be some sort of relationship. And as you can see from this example with the x's, which is our actual results, plotted over the last number of periods, it does appear that there is an element of a relationship. So now what we need to do is we need to find out how we can identify that relationship, and then once we've identified it, we can then try to predict future costs based on our levels of quantity of production. Okay, that sort of makes an element of sense. The high-low cost estimation method uses the highest and lowest quantities of production. So it uses the highest and lowest quantities of production as our two key data points. And what it does is it will join those 2 points together, and it joins those 2 points together to form a straight line, which gives us this type of relationship, which allows us to see that, yes, there is some sort of element of a relationship between total costs and total quantity of production. Now what it does is it uses a little bit of algebra, a little bit of simultaneous equations to allow us to identify the fixed cost element, which is where this line goes through the y-axis with my dollar sign on it. And then also it allows me to identify the gradient of the line, which is my variable cost per unit. Okay, so what we're going to do is we're going to use actual results from the past to try to identify fixed costs and variable costs. So we're going to use actual results from the past to try to identify fixed costs and variable costs. That now means that I can potentially try to predict what my cost should be in the future. Brilliant. Okay, how does this work in the real world? We've got a couple of examples. We're going to go through an example with regard to oranges, and then we're going to go through an example with regard to apples. And what happens with regard to oranges? If you're going to sell some oranges, you can sell oranges at $4 each. However, if you want to sell them at $4 each, you need to have a crate to hold them as well. The crate to hold them will cost you $100. That now means that the total cost of a crate containing 40 oranges is going to be the $100 plus 40 lots of $4. That gives me a total of $260. The $100 becomes your fixed costs. So the $100 becomes your fixed costs. The $4 becomes your variable cost per unit. Okay, that sort of makes an element of sense. If we now have a situation where you're going to sell a crate with 15 oranges, your fixed cost stays the same as $100. Your variable cost per unit is the same at $4, but the number of oranges has gone down. That now means my total cost associated with 15 oranges in a crate will now only be $160. So these bits of data will be collected from actual results in the past. Okay, Ed, I understand where you're going with this. Yeah, we've got some numbers here, but what does this now mean? Well, what we're going to do is we're going to use an equation which says y equals a plus bx. Hang on a minute, that's algebra? Yeah, that's exactly what we were doing before with that graph. So that graph with a straight line, this is a way of expressing the straight line. And with this straight line, what this now means is y is your total cost, which was the dollar sign. So y is your total cost, which is the dollar sign. A is the fixed cost of the crate, which is where the line goes through the y-axis. So that's where the line goes through the y-axis. A being your fixed cost, that now means that B becomes your variable cost per orange. So B is the gradient of the line. Okay, yeah. And then X is the number of oranges, because the quantity, the Q figure that we're looking at, that was my x-axis. So there's my y's and my x's and then my a's and b's. Okay, right. How are we going to do this, Ed? What we're going to do is we're going to say, for 40 oranges, our total cost comes in as $260. That $260 is made up of a fixed cost element, which is A, and then 40 variable cost elements, which is B. If we had 15 oranges, our total cost comes in as 160, which is my fixed cost A plus 15 variable cost B. So there's my two simultaneous equations. And now what we're going to do is we're going to solve these equations to try and find out what A and B are. A being my fixed costs, B being my variable cost per unit. So if I put these two equations next to each other, the highest goes on the top. So always put the highest levels of production at the top. So it's the 40B, which I'm really interested in. That one goes at the top. And then the 15B, which is the lowest one, that goes on the bottom. Now what I'm going to do is I'm going to keep that equal sign in the same place. I'm going to take 260 minus 160 on the left-hand side. And then I'm going to take A plus 40B minus A minus the 15B. So 260 minus 160 on one side. That must now equal the same amount on the other side as A plus 40B minus the A minus the 15B, because we've taken exactly the same amount from both sides of the equal sign. That now means 260 minus 160 gives me 100. And we now have A minus B, which cancels out. And then 40B minus 15B. Well, 40 oranges minus 15 oranges gives me 25 oranges, which means that my variable cost per orange is going to come in as $4 per orange. That's perfect, because that's exactly what we had before. Now what we can do is we can take that B equals 4 and substitute it into any of our equations. So if we take the 260 equals A plus 40B, we now know that B equals 4. That now means that 260 equals A plus 40 multiplied by 4. Brilliant. We've now got an instance where we can work out what A is going to be. A now comes in to be 100. So A is $100, B is $4. That's exactly what we thought the answer was going to be, because we set that answer up to start with. But I need you to understand the methodology of how we work our way through that to make that happen. Right, here's another example. This time what we're going to do is we're going to come up with a slightly different example. We're going to look at apples instead of oranges. And with regard to our example of apples, what now happens is the total cost to produce apples are made up of a variable cost per unit and then a fixed cost. Think about the crate example before. Actual results that we have. We've got total number of apples, we've got total cost. Total number of apples being 18, total cost is 186, total number of apples is 5, total cost becomes 95. Okay, what we're going to do is we're going to use y equals a plus bx. You use the simultaneous equations to find the fixed cost and the variable cost. We can now try to identify what the future costs will be based on that A and B figures that we've found. If you want to have a go at this, guys, pause the recording and have a go at the simultaneous equations. And then when you come back, just press play again and I'll go through the answer. Okay, hopefully you have had a go at this. What now happens is we look at the highest level of production, which is our 18 apples. And then we look at the lowest level of production, which is our 5 apples. We now take the 186 minus the 95. And then that will give us A minus A cancels out. It gives us 18B minus 5B, which means that we end up with 91 equals 13B, which means that my variable cost per unit comes out as $7 per unit. Wow, that's amazing. So apples are $7, oranges were $4. So apples are more expensive. Yeah, maybe not. I suppose it depends what part of the world you're in. What this now means is 95 equals fixed cost plus 5 multiplied by B. B is 7. That now means that 95 equals A plus 35. So my fixed cost becomes $60. Wow, that's amazing. And we can now use that variable cost per unit and that fixed cost to try to predict future costs in the future, which means we can have better quality planning. Absolutely amazing. Hopefully that all makes sense. Go through that a couple of times if you're not sure about it, guys. Part 2, we start putting in some other funkiness, such as a step in the fixed costs. And we look at things such as reductions in variable costs because of bulk purchase discounts. Apart from that, thank you very much for your time and attention there, boys and girls. I hope you've enjoyed your time at the beach, and I will see you all there very soon. Take care and goodbye.